Today we'll be talking about what is called organic chemistry. That is a topic under chemistry. We have organic chemistry. So, this topic is a very broad topic in chemistry. So, I believe you guys have the, let's say, preamble knowledge about organic chemistry. They say organic chemistry is the study of chemistry of carbon compounds. So, I believe you guys know that elements forms compounds. So, whereby if we combine two or more elements, we have compounds. Then also compounds forms mixtures. When we say mixtures, mixtures contains two or more compounds. So compounds are formed by two or more elements. So two or more elements makes a what? A compound. So now, talking about organic compound now, or organic chemistry rather. Organic chemistry is the study of the chemistry of carbon compounds. That is, compounds that contains carbon. So when you see a compound that contains carbon, so it's all you can call that kind of compound organic. We can call it carbon compounds. Now, as example, so let's say we have carbon 2 oxide or carbon 4 oxide. Carbon 4 oxide, it contains carbon, so it implies that it is a what? A carbon compound. Or let's say we have carbon 2. It's also a what? A carbon compound. Or let's say we have triazocarbonate, like we have CO3 2 minus. This also a what? A carbon compound. Why? Because it contains what? Carbon. Or let's say we have methane, CH4. CH4 is also a what? A carbon compound. So and so on and so forth. Now, organic compounds can have different sizes. Like example, when we say methane now, this last one I use, the methane has only one carbon atom per molecule. That is, we have one carbon atom of methane, or we have one carbon atom. Let's say we have, let me see, I can split it. Okay, let's say we have one carbon, then we also have four hydrogen. So let's say if we had one carbon plus four hydrogen, it can give us methane as example. So now the carbon is just one, then the hydrogen is what? Is four. Now because we have one carbon atom, so it doesn't mean, or we can also call it a what? A carbon compound. So we can have as many as we can. We can have the one that has two carbon atoms. Let's say example like ethane. We have C2H6. I'll be explaining all this compound very soon. But I'm just trying to explain what is carbon compound. So carbon compound in short means that compounds that contains what? Carbon. Now we have two carbon here, and we have two carbon atoms here, and we have six hydrogen atoms here. So organic compounds can have different sizes. Now this size now is more than this size here. Why? Due to its what? Carbon atoms. Now we can also have glucose. Glucose now, it has six carbon atoms. We also have soap. Soap has 18 carbon atoms, and so on and so forth. Now carbon is able to form a great number of compounds because of its ability to form long carbon. So like the carbon-carbon chains. Like in this form now, this C2H6 now can be in this form, or this CH4 can be in this form. Let's say this is C2H6. We have carbon-carbon bond, then you can have H here, H, 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 and H. Now, due to its ability to form long carbon-carbon chains, so it has great number of compounds. Carbon has great number of compounds. Now, I've given you different examples of organic compounds. Now, okay, talking about organic compounds now. The one I explained previously was just about carbon compounds. Now, organic compounds contains carbon and hydrogen. When you say organic compounds, you'll be seeing carbon and hydrogen. So now, this methane here is a what? is an organic compound. And also, this ethane here is also what? Organic compound. But if you look at this CO2, the CO and carbonate here, these three are just what? Carbon compounds. Why? Because it only contains carbon. Because we have carbon in them, so we call them carbon compounds. But this CH, we can call it carbon compound, or we call it organic compound. Why? Why is it organic? Because it contains carbon and hydrogen. Now, so another example can also be pentane. We can also have what we call ethene. We can also have what we call benzene, and so on and so forth. Now, the ability of an element to form bonds between its own atoms and produce long chain is known as catenation. When we say catenation, we have what we call catenation under organic chemistry. So we refer catenation as the ability of an element to form bonds between its own atoms and produce long chain. So that's what we call catenation. That is, let's say you are trying to use, let's say smaller carbon atoms are being formed, or large carbon atoms are being formed by small carbon atoms. So it said the ability of an element to form bonds between its own atoms and produce long chain. So we refer it as what? As catenation. So, like for example, let's say the smallest of alkane group, let's say we have CH4, which is the smallest CH4, methane. Now, from methane, we can add more carbon and hydrogen to it to give us ethane. From ethane, we can also add more carbon atoms to get propane. That is, we have CH4, then we can also have C2H6, we can also have C3H8, we can also have C4H10. So, like what we are doing here is, let's say an example, we are adding carbon atoms and we're also adding what? Hydrogen atom. So there's an increment in all these compounds here. So we refer it as catenation. So the ability of an element to form bonds between its own atoms and produce long chain. So if we had two carbon, if you add one more carbon atom to this methane here, and we add two more hydrogen atom, then it will form ethane. So this is what we call methane. This is ethane. This is propane. This is butane, and so on and so forth. So I'll be explaining that. Right now, I'm just trying to explain to differentiate within all these terms. We have what we call carbon compounds. We have what we call organic compounds. Then also what we call catenation. So now let's move to the next part now. The compounds formed by carbons are being divided into two major categories. So we have one called aliphatic, other one is called aromatic. The aliphatic can also be called open chain types. That is, when you have organic compounds in form of open chain. Like example, now look at this CH4. This CH4 can be in this form, as I said before earlier. This is CH4. If you have one carbon, they bonded with 4 hydrogen atoms. So this is an open chain. Look at C2H6, ethane. You have 2 carbon atoms bonded with 6 hydrogen atoms. So this is also an open chain. Now the aromatic, that one will be a closed chain. Like example, if you have benzene, let's say benzene. Benzene is 6,6H6. That's the formula for benzene. Now it will be in this form. If you have C in this form, so they will be bonded with hydrogen atom. Let's start with 1 2 1 2 1 2. So we have 1 2 3 bond here, and it must be 4 bonds with the carbon. So let's say we're having one more bond here. Now it is now 1 2 3 4. So it must be 4 bonds with a what? With a carbon. Now 1 2 3 4 now is complete here. Then here also you have 1 2 3. So let's put one more here. Then here also you have 1 2 3. So let's put one more here. Then here also you have 1 2 3 bonding with this carbon. Sorry. So this carbon here, 1 2 3. So put one more here to make it what? 4. Now it is now 4 bond. Here this carbon also here we have 1 2 3, then 4. Then this carbon here also we also have 1 2 3. So let's put one more here to make it 4. Now we have 1 2 3 4 5 6 carbon atoms. Now how many hydrogen? 1 2 3 4 5 6. So this is aromatic what? This is aromatic type of what? Carbon compounds. So now I said the compounds of the organic compounds can be in two forms: aliphatic or aromatic. Now when we say aliphatic, the aliphatic one are the open chain. So we refer the aliphatic, they said this may have open chain structure. So the structure of methane now is open. The structure of ethane is also open. But okay, ethane and so on and so forth. We can also have butane. We can also have ethane. So they are in open chain form. So we'll be treating all this one by one later, but I'm just trying to just differentiate or to explain all those key terms in organic reactions we have under organic compounds. So we have 4 different reactions for organic compounds. The first one is substitution reaction, addition, polymerization, and lastly the condensation reaction. So the first one, which is substitution reaction. Substitution reaction takes place in saturated compounds. So like I said previously, I said the aliphatic compounds are compounds that are open chain, right? And I also said aromatic are the what? They are the one that are closed chain type. Now we also group organic compounds into, we group them into saturated and unsaturated. So saturated compounds, so these are compounds like I said previously when I was talking about the aliphatic. I was talking about aliphatic. So now substitution reaction takes place in what? Saturated compounds. So these saturated compounds are those containing single bond. So like example, like I said previously, I showed you methane, CH4 or no, ethane rather. Let's use ethane. It has 6 carbon atoms. It has 2 carbon atoms and 6 hydrogen atoms. So this is ethane bonding with single bond. You can see single bond. So when you see organic compounds with single bond, so we refer it as what? Saturated compounds. Now if we have double bond in them, then we refer it as what? As unsaturated compounds. Now the first one, substitution reaction. This substitution reaction it goes with saturated compounds, like that is compounds that contain single bonds. But if you have addition reaction, it goes with the one that has double bond. Like example, ethane or ethene. Formula for ethene is C2H4. That is, I'll be explaining how they got that, but just listen right now. C2H4, that is, it has 4 hydrogen atoms. So C2. So there will be double bond in it. Then we have hydrogen here, hydrogen, hydrogen. They also have, sorry, this one is not there because it must be four bonds. 1, 2, 3, 4. So we have hydrogen here and hydrogen here. Here also 1, 2, 3, 4. Sorry, 1, 2, 3, 4. Now, so the formula is C2H4. Unlike ethane is C2H6. This is ethane, and this is ethane, ENE. Then this one is ANE. Now, I will explain the difference between them very soon. So the substitution reaction, like I said, it goes with what? The one that has open chain, that is aliphatic, that has open chain of single bond. Then addition reaction goes with the one that has open chain of double bonds or close chain of double bonds. So let's give an example. In substitution reactions, hydrogen atoms are replaced by more electronegative atoms of same valency. So let's say you have it. Let's use methane first. CH4. So look at methane, CH4, bonding with, let's say it's bonding with 2 chlorine, that is chlorine gas. Now, 1 atom of chlorine will be replaced by 1 atom of hydrogen here. So it will now give us, we'll be having CH3, then we'll be having Cl, then plus, so the remaining chlorine atom will be added with hydrogen atom that we remove from this place, so to give us what? HCl. So whereby it forms chloromethane, and what? We substitute 1 chlorine atom with 1 hydrogen atom. So we replace this with this, so it gives us chloromethane and hydrogen chloride. That is 1 hydrogen here with 1 chlorine here give us hydrogen chloride. Now that's about substitution reaction. So we can also have what called addition reaction. The addition reaction implies adding, let's say we're adding to the double bond of organic compounds or triple bond of organic compounds. So as I said before, the one that has a single bond, we refer them as what? Saturated compounds. Saturated compounds. While the one that has double bonds or triple bonds are referred as what? Unsaturated compounds. So addition reaction takes place in what? Unsaturated compounds. Now, let's say an example. Let's use ethene. You know ethene is C2H4, whereby we are having C with double bond, then we have 4 hydrogen. So as I said before, I said it must be 4 bonds with the carbon atoms, that is 1, 2, 3, 4. So for a single carbon atom, it must be 4 bonds, 1, 2, 3, 4. Then here also you have 1, 2, 3, 4. Now, so this ethene bonding with, let's say bonding with hydrogen gas. Now, what we did here was that we remove 1 hydrogen for chlorine, but here we'll be adding all the hydrogen gas to the what? To the ethene. So it will be giving us what? It will be giving us C2H6. Now our H was 4 before, now it will be H6. So if you're having C2H6, this is C2, we can't have double bond here again. So you'll be having a single bond all through. So we can have our complete H as 6. Now we have 1, 2, 3, 4. You also have 1, 2, 3, 4. Now it has made this into what? Saturated saturated what organic compound. Now it means addition reaction to to compounds that has double bonds, we make it what that has single bond. So because we added hydrogen gas to this, so it has turned this into what saturated. So it is no more what unsaturated now. So we added this to this to make it what saturated compounds or organic compounds. So that was about addition reaction. So the next one is polymerization reaction. When we say polymerization reaction, it implies joining simple single compounds. Number 3, let's say we have polymerization reaction. So when we join, let's say we join simple single compounds together to now form a giant compound or a giant molecule. So that it means you have polymerized the compounds. So example, let's say we join, let's say 3 ethene compounds. Let's say we have C like this one plus C2H4 again plus C2H4 again. Then to now give us what a giant what molecule. So that giant molecule, since you have 1, 2, 3, 4, 5, so you have 6 carbon atoms here. So you'll be having how many carbon atoms here? You'll be having what? 6 carbon atoms. 1, 2, 3, 4, 5, then 6. So bonding with how many hydrogen? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 hydrogens here. So here also we are having 12 hydrogen. We're having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So since we have 3 single compounds here giving us giant molecule here, so it means this is polymerization reaction. So let's say we polymerize these 3 single compounds to make it a giant molecule. So this is ethene, and ethene, then giving us what? Polythene. We can call this polythene. So this is polythene, and this is what? This is 3ethene. So that is what we call it what? Polymerization reaction. And lastly, which is number 4, condensation reaction. We have condensation reaction. Now, condensation reaction is the joining of 2 compounds to form a large one with the elimination of a simple molecule such as water. In this reaction, we'll be joining 2 compounds also, just like the previous one, just like this one. So when we join compounds together like that, so the reaction will imply that we'll be having a large molecule, so a larger one molecule, whereby we'll be eliminating water. That is, we'll be eliminating simple molecule like water before we can form our product. So let's say we have 1 molecule of ethanoic acid. So let's say you have 1 molecule of ethanoic acid, which is C2. When we say ethanoic acid, we refer it as carboxylic acid containing COOH. I will be explaining all this very soon, but I'm just trying to explain the kind of reactions we have under organic chemistry. Now, the ethanoic acid, as I said, has COOH. Now, we are replacing 1 atom of let's say ethane, because it's from the family of ethane. No, ethane is C2H6. So if you remove one, it will be C2H5. Then we'll be adding COOH. This is ethanoic. Now we are having C2H5 COOH. This is ethanoic. I'll be explaining this again very soon, but I'm just trying to explain, as I said, the reactions we have under organic chemistry. Now, if 1 mole of ethanoic acid will undergo condensation, so that is the condensation reaction, so with 1 molecule of ethanol, the ethanol, these are the group of OH, whereby the C2H6 of alkane or ethane, if you remove one of it, it will be C2H5, then replacing that one hydrogen with OH. So this is ethanol. This one here is what? Ethanoic acid, C2H5COOH. This COOH is the carboxylic group. Then the OH is also the hydroxy group. Now, for ethanoic acid is from ethane. Ethane is C2H6. So whereby we remove one hydrogen atom and replace it with what? COOH. Then also ethanol, that is OH group. We remove one hydrogen atom, then we replace it with what? We replace it with OH. So giving us C2H5OH. This is ethanol. So if we add this together with 1 molecule of ethanol, that is C2H5OH. So it will be giving us what we call ethanoate, known as esters, to form an ester called ethyl or ethyl ethanoate. So with ethanol, so it's giving us what? Esters, that is ethyl ethanoate. Now, the ethanoate formula is, as I said, it is CH3. Ethanoate is CH3COO. This is ethanoate. Now, from ethane that I said, no, ethane is C2H6. So if we remove one carbon atom here, our hydrogen atom here, it will be C2H5. Now we can add it to this and say you have C2H5 in this form, then CH3, then COO. Or we say CH3COO, then C2H5. So this is ethyl ethanoate. So I can call this one, I can call it C2H5C. Okay, let me say, sorry, I can call it CH3COO. Then I should now put C2H5. All these things I will still explain later, but I'm just trying to show you how it goes under condensation reaction. Now, so ethanoic acid with ethanol have reacted, then they give us what? Ethyl ethanoate. So we qualify it as esters. These are esters, which is ethyl ethanoate. Then for the, okay, we find this one as ethanol. Then this one is called what? Ethanoic acid. Now this is the OOH group. This one is the OH group, and this one is what? The CH3COO group. So ethanoic acid plus ethanol will give us what? Ethyl ethanoate. So what will happen? So if you have C2H5 here, then we have C2H5 here. How many carbon atoms is there? We have 2. Plus this one we have 3. Then here we have 2. So 3 plus 2, we have 5 carbon atoms here. Then here also, how many carbon atoms is there? We have 1, 2, 3, 4. This is 4. So it's not balanced yet. So it means, now I said condensation reaction implies that it will be forming esters and what? And water. So there will be water from our reaction. They said 1 mole of ethanoic acid reacting with 1 mole of what? Ethanol to form ester called ethyl ethanoate with 1 mole of water. Now we say plus H2O. Sorry, try to remove this part away. Now, so water is also formed when we react ethanoic acid with what? Ethanol. So this all about what? The reactions under organic compounds. So now in our next class now, or in our next view, I will be talking about the functional groups. So how we have the alkanes and alkynes. So under hydrocarbons. So all what I explain now, we make you understand what I will explain later. So I explained everything about the basic organic reactions. Then we talked about carbon compounds and organic compounds. Now, so in our next class now, we continue from where we stop. So thank you very much for following me. So please subscribe to Smooth Educator. Thanks.